Okay, we are looking at section 9.3 today. So I have two sequences here for you. Let's find the recursive pattern for each sequence. So for this first one, to get from 4 to 8, multiply by 2, 8 to 16, and 16 to 32, all multiplying by 2. From here, to get from 27 to 9, we would divide by 3, divide by 3, and divide by 3. Now in both of these, the pattern uses the same number over and over again, but they're not arithmetic because we aren't adding or subtracting. Instead, we're either multiplying or dividing. Sequences of this type are called geometric sequences. And just like the arithmetic ones, we want to understand how they work. That way we could use that pattern in the future. So first, this number that we're multiplying by each time is known as the common ratio. Remember that a ratio is a way to compare two numbers. So if we're comparing these two fractions, if we're comparing these two numbers, we could write it as a fraction. 8 to 4 is 8 over 4, 2. 16 over 8, 2. 32 over 16, 2. So that's why it's called the common ratio. We use the letter R, so for this problem, R would be 2. Now the common ratio will always be what you multiply by to get from one number to the next. So for B, we were dividing by 3 each time. But if we wanted to multiply, we would have to multiply by 1/3. So here's an information box for us. A sequence is geometric if the ratios between consecutive terms are the same. The nth term of a geometric sequence is given by the explicit formula a sub n equals a1 times r to the n minus 1 power. A1 is the first term of the sequence, R is the common ratio. Let's skip down here to example 1. Write the first 5 terms of the sequence using the given information. So here, A1 is 3, so that's the first term of our sequence. And they're telling us that the common ratio is 2. So in order to move from one number to the next, we have to multiply by 2. 3 times 2 is 6, times 2 is 12, times 2 is 24, and times 2 is 48. The explicit formula for this sequence, let's see, we have a sub n equals a1, so our first term is 3, times the common ratio to the n minus 1 power. So let's think about this for a second. For the first term, if I plug in a 1 here, 1 minus 1 is 0, 2 to the 0 power is 1, and so 3 times 1 gives us our first term, which is 3. But for every other term, by plugging a number in here, if we plug in a 2, 2 to the first power is 2, times 3 is 6. 2 to the second power, 2 to the third power, 2 to the fourth power. All this is telling you right here is how many times you have to multiply by 2, starting from 3. So times 2, times 2, times 2, times 2. That's why we end up with an exponent. Okay, for our next one, they give us the first 2 terms of the sequence this time. They're telling us it's a geometric sequence. So from 4 to 2, what would you have to multiply by? 1/2. Now we could finish. 2 times 1/2, 1 times 1/2, and 1/2 times 1/2. Gives us the first 5 terms. Our formula here, the first term is 4, the common ratio is 1/2, and our exponent is n minus 1. here are 6 sequences. Every sequence on this page is geometric. Push pause and work through these. See if you could find the formula for each sequence. Okay, now at the beginning of each table, I have a box. That would be for the 0 term. So if you could find those, that's great. But do we actually need it in order to figure out the formula for the sequence? Well, over here, you need the first term, you need the common ratio, that's it. So that's one difference between a geometric and an arithmetic formula. So just so you know, I'm not going to go through finding these because it's not necessary for the formula. Okay, for example 1, our pattern from one term to the next is to multiply by 3. The first term is 5, so our formula, 5 times 3 to the n minus 1. Now this one, we're decreasing, so it's a division problem. But what would I have to multiply 16 by in order to get 4? Well, 16 divided by 4 is 4, so our multiplier must be 1 over 4. But if I hadn't given you 16 and 4, if all I gave you was 256 and 64, unless you had a calculator in your hand, it might be a little bit tougher to come up with that number. So here's something that we can do. For any sequence, the common ratio will always be the second term divided by the first term. So again, a lot of times you might not need this. You could just look at the numbers and find it yourself. But if the numbers are more complicated, this will always work. So in this case, 64 over 256, which reduces to 1 over 4. Our first term is 256. So the formula for the sequence, 256 times 1/4 to the n minus 1. Alright, example 3. Remember, don't worry about fractions. Just think of this as 2 separate sequences. So in the numerator, to get from 2 to 2 to 2, we're multiplying by 1. From 1 to 3 to 9, we're multiplying by 3. So we could see that our common ratio is 1/3. But they don't give us that first term. So we could work backwards, and if you figure that out, that's awesome. But if you're having trouble, we have our first term would go in this box. We would have to multiply it times 1/3, and we would end up with 2. Now you have an equation. We could solve this by multiplying by 3 on both sides. So our first term is 6. Our formula, a sub n equals a1 times r to the n minus 1. Now example 4, try to make it a little bit tricky by not giving you 2 consecutive terms. We skip over one. But it is a multiplication problem. To move, in all these problems, to move from one box to the next, we're multiplying by something. So here, I don't know what that something is. How about r? And then from the second to the third box, I multiply by r again. So I'm starting with 3. I'm multiplying by r twice, so r squared. And when I'm done, I'll be at 48. Divide, so r squared is 16. Square root both sides. The common ratio is 4. We already know our first term. So the formula for the sequence, a sub n equals a1 times r to the n minus 1. If you haven't done it already, push pause, see if you could find the common ratio for 5 and 6. Okay, so for these two, the terms I gave you are much more spread apart. So here we could easily see once, twice gets us there. we're going to use that same process. We're going to start at 4, and we're going to multiply until we get to 32,768. The question is, how many times do we have to multiply by r? Well, we're starting at the second term, and we're moving to the 15th term. So that is 13 spaces away. So we have 4 times r to the 13 equals 32,768. Divide by 4. We get 8,192. Now, in order to figure out what r is, we need to take the 13th root of both sides. So remember, on your calculator, to do the 13th root, you're looking for that button that is the square root but has an x in front. So on these blue calculators, it's this one right here. So you have to type in which root you're finding first. So 13 root 8192. So the 13th root is 2, and that is our common ratio. We could work backwards one. What number times 2 equals 4? So our first term is 2. A sub n equals a1 times r to the n minus 1. Alright, same process here. We are moving from 5 to 13, so that is 8 spaces. We're starting at 48. So 48 times r to the 8th power will be 314,928. Need to 5, so r to the 8th is 6,561. So this time we need to 8th root 6,561, and our common ratio is 3. I also made it harder for us to work our way backwards to find the first number. So you could keep dividing 48 a few times until you get there, or we could use the same process. My first term is a sub 1, and I need to move from 1 to 5, so 4 spaces. Our first term times r to the 4th power will equal 48, but we just figured out that r is 3. So a1 times 3 to the 4th is 48. a1 times 81. Divide both sides. 48 over 81. And we could reduce that. When we reduce it, we get 16 over 27. So our formula here, a sub n equals 16 over 27 times 3 to the n minus 1. Now you go ahead, look over what we did here, and summarize for yourself, how do you find r, and how do you find a1? The easy ones, they're easy, you just look at the pattern. But take a focus here and try and describe what's happening in these harder problems.